Okay, so we're going to find the Gateaux differential of this functional here. And the functional is s of y equals g y of b, so that's another functional here, plus a quarter times this integral here from a to b with regard to x, 2y prime squared minus 2y squared, where y prime and y are also functions of x. And our boundary condition is y of a equals a, and we're also given that this term here, h of a equals 0. So we're looking like this could be an admissible function here where h of a equals 0. We could also probably find that h of b is 0, but we're not given that result yet, so we probably have to look into that further to find that. Okay, so Gateaux differential. So first of all, we need to find this function here with regards to y plus epsilon h. So now what we do is s y plus epsilon h. So wherever we see a y, we need to do epsilon h on top of that. So I've got our functional here, g, and then we've got y plus epsilon h with regards to b, and that will all go in one bracket, plus a quarter times the integral from a to b dx 2y prime. So now our epsilon h will be epsilon h prime. So that's 2 times y plus epsilon h prime and all squared minus 2 times y plus epsilon h squared. Okay, so that's all that there. Close the bracket. Okay, now for the rest of this calculations here, I'm just going to remove this bracket just so it looks a little bit less confusing. I know technically I should keep that in because it's all in the integral, but I'm just going to take that out now. I'm just going to let you know that. I hope that's okay. Okay, so next thing we do now, we've got this stage, we need to now take the derivative with regards to epsilon. So the derivative with regards to epsilon, sy plus epsilon h. Okay, so we need to use the chain rule on this one. So this one with this one, and then the chain rule, we need to find the derivative of the inside. So now we're going to have g prime of y, call that y of b, plus epsilon h of b. So that's taking care of the whole part of it. And now by the chain rule, we need to take the derivative of the inside. So I'm going to use the b, put the b with each of these functions. So now we can see what's going on. So derivative with regards to epsilon of y of b plus epsilon h of b. So now you're going to be able to see what's going on now when we take the derivative with regards to epsilon. And the next part of the line will be plus, don't forget the constant multiple 1/4, a to b with regards to x. Now we can take the derivative inside the integral because epsilon doesn't rely on x, so these are both independent of each other. So we can take the derivative inside the integral. So now by the chain rule, bring the 4 out front. So 4y prime plus epsilon h prime. And then by the chain rule, take the derivative of the inside with regards to epsilon, which is just h prime. And now we're going to subtract. So pretty much the same deal as we did here. So we're going to get 4 times y plus epsilon h. And then derivative with regards to epsilon here is just h. So now you'll see I've just stopped using the brackets. Hope you don't mind that, but I don't want to get too confused with too many brackets on there. But it's all under the same integral. Okay, so now continuing with the derivative with regards to epsilon, just need to tidy up this part here. This part here is already taken care of. I'm happy with that part so far, but now we just need to take care of this. So derivative here with regards to epsilon here, this is the bit we need to look at now, is here. Just tidy that up. So we've now got g prime y of b plus epsilon h of b. And then this one here, due to regards to epsilon here, using the chain rule, this is just going to give us epsilon h of b will just become h of b. So all we're going to do now is just multiply this by h of b. This term here, y of b, there's no epsilon in that, so that term there would just disappear. So that takes care of that. So let's just write out this just a little bit more tidier. Plus a quarter a to b dx 4 times y prime plus epsilon h prime times h prime minus 4 times y plus epsilon h times h. Okay, so now we can see that these 4's, when brought out to the front of the integral, they will all cancel. So those can all be sorted out on the next slide. So now what we do, set epsilon to be 0. That's the final part of the Gateaux differential there. Y plus epsilon h equals, so this here becomes 0. This term here becomes 0. And this term here becomes 0. So it's this term, and this term. So basically, setting the limit as e approaches 0, as epsilon approaches 0, that's basically all we're going to do now. So that gives us g prime y of b, that's disappeared, and then all we're left with now is h of b. So just one set of brackets there, that's getting rid of that, that's fine. And then plus a to b, the quarter and the 4's can all disappear now. So now we're left with y prime h prime minus 4, sorry, without the 4, sorry, yh. So minus yh. And that's regards to x. Okay, so now we can do better. So we can now use integration by parts to get rid of the h prime. So now integration by parts, let's just remind ourselves of the formula. So integral of fg prime equals f times g from a to b, that's our parameter of integration, minus the integral from a to b of f prime g. So we need to work out which functions we're going to set to the f and which function we're going to set to the h, to the g. So for this one we'll set f equals y prime, g equals h, which will then give us f prime equals y double prime, and g prime equals h prime. Okay, so what we can do here now, I'm just going to leave this as it is. So now I'm just going to take care of this. This is all we're interested in at the moment. So using the integration by parts formula, so I'm going to split the integral to start with. So a to b dx y prime h prime minus the integral from a to b with regards to x, y, h. So this integral here, we don't really need to do a lot with it. That's in the form that we like. We've got y and we've got the h. This is the important bit. So as this bit's like this, we're happy with that so far. Okay, so as we're happy with this function here, we'll just take care of this function here because we're going to try and integrate out this h prime. So that's from a to b, dx y prime h prime. So using our integration by parts formula, just on this one here, so we've got f and g. So f and g is y prime h. So y prime h from a to b minus the integral f prime g, and that's from a to b as well, and that's regards to x. So f prime is y double prime and g is h. Okay, so that takes care of that. This integral here will just bring down from a to b dx y h. Okay, this bit here looks like something we can deal with. We've got the h's as they are. We just need to work out the value of this one. So let's just do this one on its own first. So we've got y prime b h b minus y prime a h a. Okay, then this integral will just carry on down. Just bring that down there. Take care of this a little bit more. The more we can do, because what we do know, we know the value of h of a. So h of a equals 0. So this term here is now going to disappear. So then that gives us y prime of b, h of b. Just be careful with our minus signs here. So we've got to subtract that, which just disappears. But then we've got another minus sign here. So a minus and a minus. So that's now going to give us a plus. And then we can do something with this integral here with regards to x, because they are both containing an h. So we can now factor out the h and do y double prime. Now this is a minus and a minus, so we're going to leave that with the minus there of y double prime minus y. But two minuses make a plus, so there we go. So that takes care of that. So now I need to just rub out a bit of space on the board, and then we're going to go to the next stage of this integral. Okay, so now I've got a bit of space to work with here. Just going to put a line across here so we don't get mixed up. So now what we got was this bit here we was okay with. So we've got g prime y of b times h of b. So that's times h of b. We was happy with that. And then this integral here, with all this work in here, we narrowed that down to this one here. So it's going to be plus y prime of b times h of b plus the integral from a to b dx gives us h times y double prime plus y. And then we could just simplify that off a little bit more. We've got h of b in both of these. So now we can write this as, actually just write it down as the answer now. So our Gateaux differential s of y comma h equals, so h of b, let's factor that out. So h of b, and then a big bracket here, g prime y of b. Plus y prime of b. That will take care of this term, and then this is our last bit here, which we just add a to b with regards to x, h times y double prime plus y. And that is our Gateaux differential in its simplest form. Okay.